Hello, everyone. It's my pleasure to give you a talk in today's ApacheCon conference. Firstly, let me briefly introduce myself. I'm from the IT department of China Merchants Bank, or CMB, and I'm responsible for architecture design, implementation, and maintenance of the big data platform in CMB. And I'm also a PMC member of OpenLogan. In today's talk, I will show that why we need the ability of SQL on anything or query across different sources, and why we introduced the data engine OpenLogan for data exploration, ad hoc query, or batch processing from multiple sources. Also, I will talk about some use cases and problem we meet in production environment and our solution to these problems. Let's begin with the challenges in today's data analysis. According to a survey recently, only 12% of data are used for critical mission, and 23% of them are redundant and obsolete, and almost 65% of data are dark data. The term dark data refers to that data are unused and we cannot get any valuable information from them. So why it's hard to enlighten dark data? About 85% people believe that the reason is lack of efficient tools. About two-thirds of people think that the reason is low quality of data. About 25% of people feel that they do not have efficient way for fusion analysis with data distributed with various places. I think it's also the difficulties we are faced with in today's work. As a fintech organization, we are good at building large, complex software systems, and we are now starting to see the rise of massive, complex systems around data. But the primary business value of the system comes from the analysis of data rather than the software itself directly. So this brings difficulties and challenges when we deal with data distributed with various places. We all know about the diversity of storage available for data, like a relational database, NoSQL database, document database, key value stores, object storage systems, and so on. They are necessary in today's big data architecture, and it's no longer possible for us to use just one of them. Meanwhile, our users, business analysts, used to the industrial standard SQL, but all these different systems do not allow you to query with standard tools. And the different query languages and the analysis tools for specific systems are everywhere. Also, it's costly and the T plus one database to transfer data from one place to another by traditional ETL method. And the ETL method is always the root cause of data explosion and cloning. As for the requirement of business value, CMB has two apps on mobile phone with almost 100 million users respectively, and more than 100 million monthly active user or MAU totally, which makes PV scale of data. These data are stored in different places, so we need federated query to join tables from datasets. And we need data fusion. We combine data and the related information from several databases so the performance of the system can be improved while the accuracy of the results can be also increased. The third one is data exploration, which use one SQL engine to provide a simple tool to achieve a basic understanding of several datasets. Okay. All I mentioned above is the reason why we are turning to OpenLogan to find a way to access disparate data sources. Like in this slide, we access Apache Big Data, relational database, NoSQL, and so on. And then we process data locally across data centers and the hybrid clouds. About OpenLogan. OpenLogan uses Presto, an established engine for open source SQL, and provide interactive query and analysis. OpenLogan continues to improve performance, reliability, and security. Has some features like active coordinate node for high availability and a scalable data source connect framework across different data centers or available zones. It also has enhanced scheduler and a planner, reliable execution like task recovery, distributed snapshot, and the dynamic filters are suitable for highly selective join scenarios, which means most of the tables on the prop side are filled out after reading because they do not match the join conditions. And the dynamic filters not only improve the query performance, but also reduce the network bandwidth cost. I will show a use case later. Okay, I will talk a little more about connector. OpenLogan Connectors API contains interface to get metadata or get all kind of handle or to split data from data sources in partition and to deliver data to the OpenLogan execution engine. It provides service provide interface for developing new connectors. And in this way, we can easily add connectors for new data sources. About the performance improvement, here is the TBCDS test result of OpenLogan and Trino or Bristol SQL. TBCDS is a benchmark which provides a representative evaluation of performance as a general purpose decision support system. We can see the performance improved much more when the test data increased from 1 TB to 10 TB. This chart shows all the 99 SQL comparison of OpenLogan release 1.2 and the Trino release 355 with 10 TB test data. Okay, now I will show some use cases and the problem we meet in our scenario. Here is the first case. Our application, such as BI system, needs high process performance of data engine, but Hive's performance is not satisfactory, so we need to copy this data in Hive to MPPDB by the ETL method. But when we use OpenLogan, our application can connect OpenLogan using standard SQL and actually access data in various formats directly on HDFS by OpenLogan's Hive connector. And we also use the metadata in Hive metadata store. The metadata is about how the data files are mapped to schemas and tables. In this way, we only need one data copy and have much higher query performance. The second case, we built a unified query engine across DCs. Here, the SQL Engine. The SQL Engine means different analysis tools. They can be deployed in any DC and then connect different sources from different DCs by the DC connector. And our user's query will be pushed to another DC's data sources if necessary. What's more, we also use the dynamic filter to reduce data transfer cost. We'll explain about it. Suppose we query in DC1 and the coordinator in DC1 will produce a dynamic filter, for example, Bloom filter. I'm not sure whether everybody is familiar with Bloom filter. It can tell you whether an element is possibly inset or definitely not inset, thus can reduce computation. The coordinate saves Bloom filter in Hazel cluster, which is in-memory storage. And if the query across DCs is needed, the query statement and the Bloom filter will be pushed to DC2, and the coordinator in DC2 will make execution plan and save the mapping of query column to execution plan's output symbols and the Bloom filter in Hazard cluster. As for the worker in DC2, the cross-region dynamic filter operator and the table scan operator will put the mapping of query column to output symbols and apply the filter. And then we will find out whether the table scan node contains remote DC table. If it does, the query will be pushed to another DC and the process will go on. Okay. The bottleneck of cross-domain query is the network problems, such as insufficient bandwidth, long delay, and packet loss between multiple DCs. As a result, the query delay is long and the performance is unstable. But OpenLogan is designed for cross-domain queries. After OpenLogan cluster in DC2 completes computing, the result is transmitted to the OpenLogan cluster in DC1 through the network. Aggregation calculation is completed in OpenLogan cluster of DC1, and this avoids network problems caused by insufficient network bandwidth and packet loss. And this solves the cross-domain query problem to some extent. Okay, these two examples show the performance improvement when we use dynamic filter. And we will see that for the SQL2, the performance is much better. The result is here. And the reason is due to dynamic filter, the data volume is reduced as table scan is performed on the right table in DC2, and the data volume participating in join operation in DC1 is also reduced. Okay, in the use case 3, we meet some problems in performance optimization. It's a BI system before we deploy OpenLogan. We just use BI application to pull the data from Killing, the multidimensional OLAP engine, and the other sources where data is stored in CSV files. Our analysts complain that they should wait quite a lot of time for the application building reports, about a few minutes. So we use OpenLogan here to accelerate building reports. It also can connect more data sources than the former way does. However, it turns out to take much more time than we expected. As the test result, in scenario 1, 15,000 rows in Killing join 5,000 rows CSV, and we get the result about 10,000 rows. We can see that the formal method is almost equal to the method OpenLogan involved. And it's similar in scenario 2 and 3 when it comes to the detailed data. In scenario 4, performance is improved, but it still takes much more time than our business requirement. So what has happened? Killing facilitates fast data analysis by using a multidimensional data cube. Data is pre-computed, re-summarized, and stored. We do have a sub-second query experience if our application connects to Killing directly. But when OpenLogan is deployed, it actually adds one more step in the pipeline. And if the sub-query optimized and pushed down by OpenLogan, it cannot hit the cube of Killing. Just calculate from the original detailed data, and the Killing can hardly improve the performance in this way. So from this case, We know that we should set the right scenario for every tools, including OpenLogan. So this is our next work. We develop a unified SQL engine to apply routine policy for different query. OpenLogan focus on connecting Apache Big Data tools like Hive, HBase, or so on. As for the relational OLAP like ClickHouse and the multidimensional OLAP like Killing, the SQL engine directly connect them. For the case I mentioned before, we use OpenLogan to connect a Hive cluster. It's the data source of Killing, and the overall performance is much better than before. OpenLogan community has provided ClickHouse connector. Uh, we still work on how to take advantage of the features of Killing and the ClickHouse when we use the connector respectively. The last thing is about the rules we learn from production cases. The very important thing is how to reduce the impact on data sources. We don't recommend that OLTP database with real-time trading works as the data sources because we should avoid performing both OLTP and OLAP activity within the same database. Then they will not interfere with each other and hurt your application's performance. And even for OLAP database, we develop monitoring tools to detect slow query in sources. And the second one is we apply different push down policies for different sources. We don't push down join operation for relational database. We directly connect to HDFS and the metastore of Hive cluster, which I mentioned in the use case before. We access data node of our MPPDB directly instead of connect the coordinate node. As a conclusion, data infrastructure is undergoing rapid fundamental changes at the architecture level. Building out a modern data stack involves a diverse set of choices, and making the right choices is more important now than ever. We know that the OpenLogan is a powerful SQL query engine for big data analysis. The key of high performance is to find the appropriate scenario as well as good performance turning skills. So, welcome to join the community. We can find more scenarios, enlighten more dark data, and strengthen the OpenLogan engine together. Okay, you can find me by this email or on the Slack. Okay, that's all. Thank you.